Now for our next example, we're going to use all the postulates, theorems, and converses together, and we're going to work it through. For the number 1 through 8, use the diagram and given information to determine which lines are parallel. State the reason, in other words, the postulate or theorem used to make that determination. Now this is a pretty busy picture, and you already had one like that in our previous in-class practice, and you may remember that I told you just take a piece of paper and cover up the part that you don't need to make it less confusing. I'm going to do just that, and I'm going to start with number 1, where I'm told that angle 9 and angle 16 are congruent. Well, let's find angle 9 right here and angle 16. These two angles, we're being told, are congruent. If these two angles are congruent, what theorem are we actually using here? We are using the alternate exterior angles converse. Remember, it's the converse because we've been told that the angles are congruent. We don't have to figure that out. We've been told that they're congruent, and they are alternate exterior angles. Alternate exterior angles. And what does that mean? Let's not forget it was the converse. Let's just put that down. And that means that which lines are we talking about here? Take a paper away. We're talking about lines M and L. Lines M and L are congruent. Excuse me, are parallel. I'm going to make the L like this so we don't get confused over here. Lines M and L are parallel. Alright, let's move on to number 2. Angles 8 and 11. So let's find where 8 and 11 are, and let's move our piece of paper so we can cover the stuff we don't need. 8 and 11. Angles 8 and 11 are congruent. These two angles are alternate interior angles, and therefore we're using the alternate interior angles convert. Alternate interior angles converse. And which lines are we talking about? We are talking about lines N and Q. These lines are interior angles inside of the lines N and Q. So N is parallel to Q. Alright, guys. Getting better. So, angles 5 and 7. Angles 5 and 7 are congruent. I'm going to keep using my paper for just a little bit longer. So, this is angle 5. This is angle 7. What are angles 5 and 7? They are corresponding angles. They're in the same position along the different two lines. So the corresponding angles converse. This is what we're using here, and we are talking again this time about the lines M, which is parallel to L. M and L are parallel. Alright, now we have something different here. Let's look at that. Angles the measurements of angle 6 and 7 are together 180 degrees. What does that mean again? That means they're supplementary, right? Where do we have 6 and where do we have 7? Our picture's getting really colorful as of this point. Angle 6 and 7 are supplementary, and that means that we're using the consecutive interior angles converse. Consecutive interior angles converse to realize and find out, and we already knew that, by the way, that lines M and L are parallel. We got more problems, but we also got more colors, so let's keep going. So now we have our angles 6 and 7, and we are also finding out that they are congruent. Just a little side note here, what does that tell us actually, that two angles are at the same time supplementary and congruent? Well, they add up to 180 and they both have the same measurement. That means that they both have to have a measurement of 90 degrees. That's just a little side note, right? Playing with our concepts and putting them together. However, let's talk about it. These two angles are consecutive interior angles, but the fact that they're congruent as such doesn't help us out. We don't have a postulate or theorem that tells us anything about that, because we only know that they're 90 degrees in connection with the previous information. It could be any other measurement. So therefore, that doesn't help us, and that does certainly not tell us that the lines are parallel. So there is no postulate or theorem that tells us anything about whether the lines are parallel or not. Just very important to keep that separate. With the information of number 5 alone, we cannot find out anything at all. It was information in number 4 that told us that M and L are parallel lines. Let's move on to number 6. Tells us that the angles 1 and 9 are congruent. Well, let's find those angles first. This is angle 1, this is angle 9. Angle 1 and angle 9 are corresponding angles, and they are congruent. So this is the corresponding angles converse. And that corresponding angle converse tells us that the lines, I'm moving my paper for you guys, but you see that on your notes, N and Q are the ones that are parallel. Moving on to number 7. Measurements of 1 and 9 added together are 180 degrees. 1 and 9 are therefore supplementary angles. And we're talking about the same 1 and 9 as in the previous problem. And we said these angles are corresponding angles. They're certainly not consecutive interior angles, because number 1 isn't an interior angle. So the information that they're supplementary doesn't help us at all. We cannot use any of our postulates or theorems. And last but not least, angles 13 and 12. Let's look at 12 and 13. 12 is right here, and 13 is right there. Those two angles are exterior. They're actually alternate exterior angles, and they are congruent. So this is the alternate exterior angles converse. And this converse tells us one more time that lines M and L are parallel. So there are a few other types of problems we can solve using these postulates and theorems. Look at number 9. Solve for x. Solve for x. Always Want to put in and use a little bit of algebra in these situations too, and state the reason, in other words, the postulate or theorem you used. We got to solve for x, and first of all, realize we have these nice little markers here, and they actually tell us that these two lines are parallel. So that is an important piece of information, because all the theorems and postulates we discussed today only work if the two lines that are being crossed by the transversal are parallel. Always remember that. They're going to try and trick you down the road. So remember, these only work for parallel lines. So we got two angles. They are on the interior. They're between the two parallel lines. So they are consecutive interior angles. This is the consecutive interior angle theorem. Now, why is it the theorem this time? Because we know that the lines are parallel and we're trying to find the measurement. Those are the theorems and postulates. The converses are when we don't know if the lines are parallel, but we do have some measurements. So there is the difference. And the consecutive interior angle theorem tells us that the two angles together have to add up to 180 degrees. They are supplementary. Well, then let's take those two angles, add them up together. One has a measurement of 3x and the other one has a measurement of 120 degrees. Together they have a measurement of 180 degrees. And now we're solving a two-step equation, you guys. Minus 120 degrees on both sides gives us 3x is equal to 60 degrees. Divide by 3 tells us x is equal to 20 degrees. Now, if x is equal to 20 degrees, and we already found that out while solving, we know that the angle, which is actually 3x large, is 60 degrees. 60 plus 120 add up to 180. All right, good job, you guys. Let's move to our last example. Okay, find the value of x that makes the lines A and B parallel. And again, state the reason, postulate, and theorem that you used. Here we have to find the value of x that makes A and B parallel. See, therefore, we don't have those marks yet because we don't know if they're parallel yet. But we have to find a number which will give us that answer. So we got angles x, and the other angle has a measurement of 2x minus 120 degrees. And these are two angles which are exterior. They are on the other side of the transversal. These are alternate exterior angles. So we're using the alternate exterior angle theorem. We're using the alternate exterior angles theorem. And what does that tell us? The alternate exterior angles theorem tells us that these two angles are congruent. So we're not adding them up to 180 degrees. We find out and we know and use the fact that they have to be the same. So this is how we set up our equation. And now we're going to go ahead and solve it. All right. I'm going to move my x's to one side by subtracting 2x, and I get negative x on the left is equal to negative 120. Well, we already know where we're going to go with this. Divide both sides by negative 1, and you could also multiply by negative 1, right? Same difference. And the answer is x is equal to 120 degrees. Well done, you guys. So, for your summary, I want you to compare and contrast the relationship between the measurements of the consecutive interior angles versus the other special angle pairs. Consecutive interior angles versus the other special angle pairs. And you can also think about places outside of the classroom where you see parallel lines. There are many, many places in our world, in our houses, outside, in our community, where we see parallel lines. And in some cases, they really have to be parallel. Otherwise, things wouldn't work out. All right. Great job, you guys. And I will see you in class.